Hi guys, I promised you a video with little models of this so I could show you the angle so it would be in 3D. And for some of them I have good models, and then for some of them I just have these tiny little weird ones because I wasn't able to get my entire set from my office, but you can deal with it. Okay, so when we're talking about a central atom, and I don't know if it's showing up, but there's a little bead right here that indicates a central atom. And we have two electron groups around the central atom. What happens is your two electron groups try to get as far apart as possible. So the two electrons that are stuck together in the bond, they're stuck together. But this group of electrons and this group of electrons can repel each other. And getting as far apart as possible here, that's going to give us a bond angle of 180, and you guys can see that on this slide right here. And you can also see how this molecule is linear. It's in a plane and it just makes a line. Now, if we have carbon dioxide, which has a double bond on each side, and you can see it in this model here, this is still an electron group, and this is an electron group over here too, even though they're both double bonds. So these four electrons in this double bond are stuck together because they're in a bond, and these four electrons over here are stuck together in this bond. But this group can repel this group, and we can see there that they're 180 degrees from each other. Okay, and all three of these atoms are in a line. So this molecule is linear, and we can see there we've got our linear geometry for when we have a central atom and it's bonded to two things. Now, the next thing that we talked about was three electron groups. And we said there was two ways that we would see this. But we said in 2A, mostly you'll just see the trigonal or triangular planar. Again, trigonal planar and triangular planar are the same thing. And it's called trigonal planar because you've got three things around a central atom, so that's the tri part of it. And it's planar, so you can see that all of your atoms and all of your electron groups are in the same plane. It's a flat molecule. Now, these bonds are trying to get as far apart as possible from each other because the electrons are repelling each other. And that means that this bond angle is 120 degrees. We've got 120 degrees, and here we've got 120 degrees. If you go on to Chem 1A, you guys would learn how to name this with electron pair geometry instead of using molecular geometry there. And that's a different system of naming, but I just wanted to make you aware of that. But for us, we're going to go with trigonal planar geometry, and we can draw it like this, or we can draw it like that, exactly the same thing. And then we had our last group, which is a central atom that has four electron groups around it. And the first way that we would see this is a central atom bonded to four different things there. And here we have the molecule methane, Ch4. And you guys can see that three of your atoms, these three right here, are in the same plane, but then you have one atom that comes out at you and one atom that goes back. And so that's when we learned how to draw it with our dashes and wedges. So we said that the three atoms that are in the plane, how we indicate that is with the straight lines. So I would turn the molecule like this so that these three atoms are in the plane, so those right there. And then this atom right here is coming out at me, and this atom back here is going back into the board, and that's got the dashes back there. So again, the one that's coming out at me has the wedge, going back has the dashes, and these two right here in the plane so they get the regular looking bond. Okay, so going back to the 4 electron groups, this was the first that we would see, and in order to get as far apart as possible, all of these electron groups have a bond angle of 109.5, 109.5, 109.5, 109.5, all the way around. They're all equal all the way around. And then the next way that we will see 4 electron groups around a central atom is if you have a central atom bonded to 3 things and a lone pair up there. And that looks like this guy right here, and I'm going to switch slides for us to this right here. And the most common example of this is ammonia, NH3, and it has a nitrogen in the center, and it's bonded to 3 hydrogens. We can see those, the little beads down here. And the lone pair on this model is indicated with this balloon up here, okay? So if we're talking about electron pair geometry, we still have a tetrahedral shape, but that's the system you guys would see in 1A. For us, we're going to ignore the lone pairs and just go with what shape we have when we're looking at the bonding electrons. And what that is trigonal pyramidal. And in your book, it'll say that the geometry for this is trigonal pyramidal because we're going with the molecular geometry system, not the electron pair geometry system, okay? So that's why your book will say trigonal pyramidal there. Now the bond angles on this, even though we have 4 electron groups around a central atom, like we did with our methane, the bond angles here are 107 degrees because the lone pairs up here, those electrons, because they're not bonding to something, you can see they puff up a little bit and it squeezes the bond angle down of these guys from 109.5 to 107. So that's why the bond angle on this is 107, 107, and 107. Now, if you have a central atom that is bonded to 2 things, so this is water, oxygen, and then 2 hydrogens, H2O, and it has 2 lone pairs. If we were looking at electron pair geometry, again, you would see that system in 1A. That would still be tetrahedral because you have 4 electron pairs around it, but again, we don't do that system. In 2A, we just do one system, which is molecular geometry, and that ignores the lone pairs, and it just looks at the molecule's shape without the lone pairs, and that's called bent or angular. But if we're looking at why the bond angle is 104 on this one instead of 107 or 109.5, it's because you have a second lone pair, and again, those guys take up a little more room than the bonding electrons, and it squishes this angle down. So we go from 109.5 to 107 to 104.5 on this one. So that's the explanation on those bond angles and what we call these shapes in this class. So in the next little video, I'm going to show you guys on paper how to draw the molecular polarity. I did it on the slides for you, but I promised I'd show you guys a little more in 3D with my models, and I'll do that in a bit.